Scientific notation is a way to write numbers in a very special way to represent very large or very small numbers in a compact form. So let's consider a couple of values. First, 7,000. Not an incredibly large number, but is starting to get larger. We could rewrite this as 7 times 1,000. And we can rewrite 1,000 as 10 to the third power. Because there are 1, 2, 3 zeros in that multiple of 10. Then for scientific notation, as just a matter of convention, rather than using that multiplication dot, we normally revert back to the x or the cross. It's not really a cross, I guess, because it's turned on its side. The x, to rewrite this as 7 times 10 to the third power. And that's that same number, 7,000, written in scientific notation. We can also do that with a very small number, like 0.0002. We could rewrite this as 2 times 1 over, this number is in the tenths, hundredths, thousandths, 10,000ths place. So we could rewrite this as 1 over 10,000. We can rewrite 1 over 10,000 as 1 over 10 to the fourth power, since we have 1, 2, 3, 4 zeros in that multiple of 10. And then using properties of exponents, we can move that up to the numerator and write it as 2 times 10 to the negative fourth power. Then that same convention with scientific notation, we change that multiplication dot to the multiplication x, and we'd write this as 2 times 10 to the negative fourth power, and we have that same decimal number written in scientific notation. A quick thing to pay attention to here. Whenever 10 is being raised to a positive value, your number should get bigger, or you should think of that as being a very large number. If 10 is being raised to a negative power, then what we're representing is something very, very, very small. And that also tells us the direction to move the decimal place to turn this back into the original value. So we can think of this 7 as 7.0, however many zeros we want to add on there. And then that 3 is telling us how many places to move the decimal to get back to the original value. So in this case, 1, 2, 3 gives us that 7,000. Similarly, if we start with this value of 2, and we think of that as 2.000, however many zeros we want to put there, that negative 4 is telling us how many places to move the decimal, but since it's a negative value, we're going to move it to the left, 1, 2, 3, 4, and put placeholder zeros in to fill in those missing spots. So this gets us back to 0.0002. So whenever 10 is raised to a positive power, that's representing a large number. Raised to a negative power is representing a very small value. What we want to do in example 6 is rewrite each of these numbers in scientific notation. Now we have more digits present, so one more step that we're going to add to this is to make it clear that when we do this, we put the first digit and then a decimal place, regardless of how many digits we have in our number. So we'll rewrite this as 2.341. And we could include that trailing zero, but we don't necessarily need it. Now what we need to think about is how many places did the decimal move to get from where it was to here. So originally, the decimal place was after that 0, so it moved 1, 2, 3, 4 places. So this will be times 10 to the fourth power. Similarly, 320,700 will be rewritten as 3.207, and we could or could not include those trailing zeros. The original decimal would have moved 1, 2, 3, 4, 5 places. So we'd write this as times 10 to the 5th power. In part C, we have 124,240,002. So we'd rewrite this as 1.24240002. Unless we were given any directions to round that, we would include all of those original digits. And then count that this moved 1, 2, 3, 4, 5, 6, 7, 8 places. So to write this in scientific notation, we would multiply by 10 to the 8th power. To do that for decimal values, we would identify the first non-zero digit as we read this number from left to right. So that would be 4. And then we would put our decimal point there and then fill in any remaining digits that we have, times 10 to some power. So we would count how many places that decimal moved. In this case, 1, 2 places. So this would be times 10 to the negative second. Similarly, in part B, we would have 2.654 times 10 to the 1, 2, 3, 4, 5, 6. Oh, I went too far. 1, 2, 3, 4 places is how far that decimal moved. So this would be times 10 to the negative 4th. And then in part C, we would have 3.84 times 10 to the 1, 2, 3, 4, 5, 6 decimal places that we moved. So times 10 to the negative 6th power.